Hello everyone, welcome to Geometry Lesson 3.5, Showing Lines Are Parallel. We're going to learn 4 new theorems in this lesson, but they're theorems that you probably already know. Before I can prove that to you, we need to know what a converse is. A converse is a statement formed by switching the hypothesis and conclusion of an if-then statement. So let's look at a couple examples of what that means. Our first if-then statement says, if an angle measures 90 degrees, then it's a right angle. The hypothesis of this statement is an angle measures 90 degrees. And the conclusion is it's a right angle. If I wanted to find the converse of this statement, I would switch these two around. So my new statement, the converse, would read, if an angle is a right angle, then it measures 90 degrees. So by switching those two parts around, I create a new if-then statement that isn't necessarily true. In this case it is, but let's look at another one where the converse doesn't work. So here I have the statement, if an angle measures 60 degrees, then the angle is acute. The hypothesis is an angle measures 60 degrees, and the conclusion is the angle is acute. Switching the hypothesis and the conclusion will give me my converse. If an angle is acute, then it measures 60 degrees. That isn't necessarily true. Not every acute angle measures exactly 60 degrees. We could have acute angles that measure 30 degrees, 45 degrees, 80 degrees, anything between 0 and 90, right? So in this case, our converse is false. Today's theorems are all converses of the theorems that we learned in the last lesson, and in this case, all of these converses are true. Our first theorem for today is the converse of the corresponding angles postulate. Do you remember the corresponding angles postulate? Hopefully you do, because we just went over that. But it says that if two parallel lines are cut by a transversal, then corresponding angles are congruent. So if you think about the corresponding angles postulate, we're going to flip the hypothesis and conclusion. So our converse says if two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. So these theorems are very different because I'm starting out with just two ordinary lines cut by a transversal, and I'm using those angles to prove that the lines are parallel. These theorems are really important for proofs because it's the first time that we can actually prove that lines are parallel. So we have our two lines cut by a transversal, and I know that corresponding angles are congruent. So I could pick any pair of corresponding angles. For this example, I'll just use angles 3 and 7, and if I know that those are congruent, then I can conclude that those lines are parallel. Let's look at our next theorem, alternate interior angles converse. If two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. So any pair of alternate interior angles, I could use angles 3 and 6, and if I know those are congruent, I can conclude that the lines are parallel. Next is the alternate exterior angles converse. So I have my two lines cut by a transversal with alternate exterior angles congruent, and I can conclude that the lines are parallel. Alternate exterior angles, remember, would be angles 1 and 8 or 2 and 7. So we'll say that we know 2 and 7 are congruent, then I can conclude that those lines are parallel. So now we have the same side interior angles converse. Remember, the same side interior angles theorem says that if two parallel lines are cut by a transversal, then same side interior angles are supplementary. Remember, same side interior angles are different from the other three angle types. So the converse of this one then says that if two lines are cut by a transversal, so that same side interior angles are supplementary, then the lines are parallel. And I can't really mark this one in my picture, so I'll just have to write it out symbolically. For same side interior angles, I could use the pair 3 and 5 or 4 and 6. And we'll use 3 and 5. So if I know that the measures of angles 3 and 5 add up to 180 degrees, I can conclude that the lines are parallel. Okay, so let's see if you can apply what you've just learned. For each diagram, tell whether you can conclude that line P is parallel to line Q. If you can, tell why. So here we have lines P and Q cut by that transversal, and I'm shown that these two angles are 105 degrees. Hopefully you recognize these angles as corresponding angles, and they're congruent. So if I have two lines cut by a transversal so that corresponding angles are congruent, then the lines are parallel. So yes, by the corresponding angles converse, these two would be parallel. In my next problem, I have lines P and Q again cut by a transversal, and I have these two angles measuring 123 degrees and 57 degrees. Hopefully you recognize these as being same side interior angles, and I have same side interior angles converse that tells me that if two lines are cut by a transversal and same side interior angles are supplementary, then the lines are parallel. So I need to check and see if these two angles are supplementary. 123 degrees plus 57 degrees adds up to 180 degrees. So yes, by the same side interior angle as converse, these two lines would be parallel. One more example like this. So lines P and Q, again cut by a transversal. This time we have alternate interior angles, and it tells me that they're both congruent. So by the alternate interior angles converse, these two would also be parallel. Now let's do a little bit more work with converses. In this example, I'm asked to rewrite each statement as an if-then statement, and then find the converse of each statement and decide whether the converse is true. So we have a lot going on here. This is going to be some good review. So first, let's rewrite this statement as an if-then statement. All ducks are birds. So if an animal is a duck, then it's a bird. My hypothesis is that an animal is a duck, and my conclusion is that it's a bird. So if I switch those two around, I'll have if an animal is a bird, then it is a duck. And to prove whether this is true or false, remember we talked in chapter 1 about using counterexamples to prove that a statement is false. To find a counterexample for this statement, I would have to pick an animal that is a bird, but not a duck. And I can do that pretty easily, so this one is false, and my counterexample will just be an eagle, but it could be any bird other than a duck. Our next example, I will get a good grade if I do my homework. So that if word, remember, tells us that that's our hypothesis. So if I do my homework, then I'll get a good grade. When I switch these two around, my converse will read, if I will get a good grade, then I do my homework. So for this one to be false, you'd have to think of a time when knowing that you'd get a good grade for doing your homework would still not make you do your homework. Hopefully for most of you, if you know that homework is necessary to get a good grade and you know that homework would help you get a good grade, and more importantly, actually learn something, you do the homework. So I'm going to say that this one is true and just hope that most of you understand the importance of homework. That's all for lesson 3.5. Remember, you can rewatch any parts of this video if there was anything you didn't understand. Thanks for joining me, and happy hypothesizing.